we are counting down the 8 most influential hi-fi brands of the 1980s that vanished from the spotlight, but left engineering lessons the modern audio world cannot ignore. From overbuilt mechanics to transformer-driven punch and pioneering circuit topologies, these entries showcase how technical ambition collided with market forces and changing consumer priorities. Which defunct brand offers the most valuable blueprint for hi-fi's future? Let's begin with number 8. Nakamichi's approach to cassette technology in the 1980s set an uncompromising standard for mechanical precision. The Dragon Deck, launched in 1982, relied on a 5-motor, dual direct drive capstan transport that delivered wow and flutter as low as 0.04% WRMS. At the heart of its design, the NAAC servo system constantly adjusted playback azimuth within a plus or minus 12 arc minutes range, using a dedicated motor to keep high frequencies crisp even with tapes recorded on misaligned machines. This level of control meant the Dragon could extract detail and stereo focus lost on ordinary decks. Jitter was kept under 50 picoseconds, a figure that speaks to the obsessive engineering behind every component. But these advances came at a price. The complexity and cost of such overbuilt transports strained Nakamichi's finances, especially as cassette sales fell sharply after 1985. Today, restoration experts meticulously lubricate bearings and recalibrate NAAC servos, preserving the measurable fidelity gains that still make these machines benchmarks for analog tape playback. Sansui's amplifiers from the 1980s stood apart for their unapologetically heavy power supplies. Models like the AU series and G series receivers often carried EI core transformers weighing more than 1 kilogram, paired with discrete output stages and matched transistor pairs. This engineering wasn't just for show. Service manuals from the era document dynamic headroom exceeding 3 decibels above rated output, while damping factors typically hovered around 60. The result was an unmistakable punch and warmth that collectors still praise, with restored units regularly selling for over $1,000. Power supply regulation in these designs kept voltage ripple below 1 volt, ensuring clean delivery even under demanding loads. But as the yen appreciated sharply in the late 1980s, Sansui's manufacturing costs soared. Attempts to cut expenses led to lighter chassis and a shift toward integrated circuits, undermining the very qualities that built the brand's reputation. Branding confusion in export markets and a failure to adapt to the digital transition only hastened Sansui's decline. Yet the demand for their transformer-heavy amplifiers remains strong among those chasing that classic analog sound. Akai's legacy in tape technology rests on its GX glass ferrite heads, a materials breakthrough that set their decks apart from the competition. Unlike traditional permalloy heads, which gradually wore down and lost high-frequency clarity, the GX design bonded single-crystal ferrite to glass, creating a surface so hard that head gap widening was virtually eliminated. Longevity reports from the 1980s showed these heads retained original playback fidelity even after thousands of hours. Head wear was measured at nearly half that of conventional alloys. This stability meant Akai decks could consistently deliver signal-to-noise ratios approaching 90 decibels, preserving tape detail long after softer heads had dulled. The same engineering rigor extended to their reel-to-reel machines, where precise transport systems and magnetic head technology became hallmarks. Yet, as the brand licensed its name to lower-cost mini-systems in the late 1980s and early 1990s, the reputation built on materials science began to fade. Today, restoration specialists value original GX heads for their enduring performance, a reminder that thoughtful materials choices often outlast corporate strategies, and that longevity remains a defining trait. Aiwa's early 1980s separates challenged the idea that the brand was only about mini systems and portables. Their high-end preamplifiers and power amplifiers, like the C22 and P22, delivered a noise floor below -100 dBu, comparable to far costlier audiophile gear. Service manuals from the era reveal modular printed circuit boards, each stage shielded and laid out for easy servicing, a rarity as competitors moved toward integrated circuits and cost-cutting. Reviewers in audio and stereo sound praised the clean signal paths, with total harmonic distortion often measured under 0.005%. These designs relied on discrete transistors and careful grounding, producing a neutral, open sound that rivaled the best from Luxman or Akai. But this pursuit of low-noise excellence faded as Aiwa's parent company, Sony, shifted the brand's focus after acquiring full control in 2002. The high-end line vanished, replaced by mass-market mini-systems aimed at younger buyers. Today, technicians still value these early Aiwa boards for their clarity and serviceability. It is a lesson in how disciplined printed circuit board design can outlast fleeting market trends. Luxman's approach to solid-state amplification in the 1980s stood apart for its careful blend of technical rigor and sonic character. Drawing from its long tradition of tube amplifier design, the company developed the Duo Beta feedback topology, a dual-loop system that balanced global stability with output stage linearity. Rather than chasing vanishingly low distortion figures through aggressive global feedback, Luxman prioritized a refined harmonic profile, low in noise and intermodulation distortion, but with a warmth and ease reminiscent of its reference tube models. Period brochures for the L507 and M05 routinely quoted intermodulation distortion below 0.02%, and many integrated amps of the era approached or exceeded 20 kilograms in chassis mass. This physical heft was not just for show. It reflected oversized transformers, generous heat sinking, and rigid construction, all aimed at delivering wide bandwidth and long-term reliability. Alpine's acquisition in 1984 briefly threatened this identity as the brand was repositioned for broader market appeal. Yet Luxman's later revival reaffirmed its core values, returning to heavy, tube-influenced hardware and a consistent voicing philosophy. The company's survival underscores how preserving a distinct sonic identity can outlast shifting ownership and market trends. Hitachi's approach to Hi-Fi in the late 1970s and early 1980s focused on a technology that quietly reshaped amplifier design, the lateral MOSFET output stage. Unlike more common bipolar transistors, Hitachi MOSFETs were protected by U.S. patents filed in 1977. They offered high slew rates, exceptional thermal stability, and a softer clipping characteristic that made overloads less abrupt and less damaging to speakers. Service manuals for models like HMA 7500 list damping factors consistently above 100, a figure that rivaled far more expensive separates. The company's own application notes explained how MOSFETs could tolerate higher temperatures and recover from brief overloads without the harsh distortion typical of bipolar designs. These advantages were recognized by other manufacturers, who began sourcing Hitachi MOSFETs for their own high-end amplifiers. Yet while the underlying silicon found a home in many celebrated designs, Hitachi's consumer hi-fi brand faded as the company shifted focus to industrial and commercial electronics in the 1980s. The lack of strong consumer branding meant that even as their MOSFET topology became a blueprint for modern audio, the Hitachi name receded from the hi-fi spotlight. Kenwood's Supreme series pushed conventional analog design to its physical limits. The Model 600, for example, relied on a massive EI core transformer with dual secondary windings, each dedicated to a separate channel. This quasi-dual mono layout fed enormous filter banks, over 22,000 microfarads per rail per channel, resulting in nearly 90,000 microfarads of total storage. Service manuals and restoration logs confirm that this brute force supply approach delivered dynamic headroom exceeding 4 decibels above rated output, with measured burst power well over 180 watts per channel before any sign of sag. Total harmonic distortion stayed below 0.001%, even at high volumes. Heavy aluminum heat sinks and short direct wiring kept thermal drift and crosstalk to a minimum, ensuring stability under load. Later, as Kenwood's mainstream lines shifted toward AV receivers and shared power rails, this kind of overbuilt supply vanished from the catalog. Today, Supreme Series amps are prized among restorers as the reference standard for what a conventional analog supply can achieve. They set a benchmark that only truly radical designs could surpass. Bob Carver's magnetic field amplifier upended expectations about what a high-power amp could be. Instead of relying on massive transformers and banks of capacitors, Carver's design, granted U.S. patent 4,359,731 in 1982, used a tracking power supply that followed the audio signal in real time. The rails would rise and fall within a few volts of the musical peaks, slashing the amount of wasted heat. Bench tests in Stereophile and Audio Magazine confirmed the results. They achieved 200 watts per channel in a chassis half the size of its rivals, with idle power draw under 5 watts and full output efficiency approaching 85%. Thermal cameras showed the M400 and M1.T running cool to the touch, even after hours at full tilt. Oscilloscope traces revealed the supply rails hugging the signal envelope, a sharp contrast to the fixed high-voltage rails of conventional Class A/B designs. While some audiophiles debated the sonic character, citing a trace of high-frequency edge at extreme levels, lab measurements consistently validated Carver's claims. The confusion between marketing hype and real engineering may have limited adoption, but the core idea, a compact and efficient amplifier that delivers serious power without brute force hardware, remains as relevant now as it was at Carver's 1982 CES demonstration. In an era chasing smaller, lighter, and greener gear, the magnetic field amplifier's daring topology stands out as a blueprint worth reviving. Across all 8 brands, one truth emerges. Uncompromising engineering doesn't disappear. It resurfaces wherever sound quality matters. The loss wasn't technical, but economic. Today's hi-fi revival borrows directly from their philosophy. In the end, durability and sonic identity outlast trends. Which brand's legacy do you wish would return? Let us know below.